OK, one final note when we talk about measuring accuracy is the fact that you can actually combine detectors. So sometimes you might have multiple detectors. For example, if we think back to fire alarms, you might have a smoke-based fire alarm, which goes off if it sees smoke or detects smoke in the air. You might also have a temperature-based fire alarm that goes off if the temperature in the room exceeds some high number. So these are two different types of detectors. They both work, and one thing you can do is combine them into a better detector. So one question is how you combine them. You could combine them in parallel or in series. And if you've ever seen like an electrical circuit, maybe these terms seem familiar. If you haven't, a parallel composition would mean that if either of the detectors go off, if we either see smoke or we see high temperature, we will alert. It just takes one of the two for the alert to happen. In series composition, you only alert if they both go off. So if there's only smoke, you don't alert. If there's only high temperature, you don't alert. You only alert if there's both temperature and smoke. That's what it means to combine in series. So which one is better? Once again, depends on a lot of things like the base rate and the cost of attacks. But in general, if the two detectors are largely independent, they're looking at two different things, you could generally say that parallel composition generates more alerts because if either one goes off, your overall combined detector goes off. Either smoke or temperature is enough. So usually, you get more alerts, and usually the trend is that more alerts means more false positives, but it means fewer false negatives. So if there is a fire, you're more likely to catch it because either one just has to go off for the detector to go off. So if you've reduced the false negative rate, you're catching more of the fires, but you're increasing the false positive rate because if one of the two accidentally goes off, then you get a false positive. By contrast, if you combine in series, you usually get fewer alerts because they both have to go off. One of them going off is no longer enough. Usually, this means you get fewer false positives. If just one of them accidentally alerts, that's OK. It won't be a false positive because your overall system will not alert. They would both have to make a mistake for a false positive to occur. That usually reduces the false positive rate, but it might increase the false negative rate. Both of them have to catch the fire for the alert to go off. If one of them misses the fire, then the detector misses the fire, and you get a false negative. So that might increase the false negative rate because it makes it harder for the detector to go off. Now, this isn't always true. Once again, depends on your specific detectors. But what we want to show here is just that there are trade-offs. So you usually cannot get both of these rates all the way down to 0. Oftentimes, you'll get cases where reducing one increases the other, and trying to find a good balance is really where a lot of work goes into finding and making good detectors. So there's no free lunch. Usually, you can't get both of them to be excellent, but there's trade-offs, and you have to find the right balance.